Well, good morning. This is lessons 25 through 27, Algebra 1. Start off with a quick review. Last week we worked on things like 5 plus x equals 7. And this we introduced as being what we call an equation, and the principle of the balance scale, that you have something on the left equaling something on the right, and it will always stay balanced. Again, equal means balanced, and it will stay true if you do whatever you do on the left equal to whatever you do on the right. So in this case, if I subtract 5 from both sides, I don't change the balance scale. Well, 5 minus 5 is 0, so I end up with x equals 7 over negative 5. That can also be written as negative 7 over 5 or negative 7 over 5. All three of those are identical. I generally will throw it where the negative sign is on the top. So, simple review. Another thing we looked at is, what if you have something like 5/7 x equals 20, and you're saying 5/7 times what equals 20? Well, you can't really do that in your head. At least most people can't. So what we're going to do is use the other property of in your math, it calls it the multiplicative property of equality. Well, ignore that. It's whatever you do to the left, you have to do to the right. Notice it's a very different thing. This top one was something plus x equals this. This is something times x equals that. Very, very different, approached differently, but the goal is still the same. What is x? I want to get x by itself. Well, to get x by itself, I need to basically think of it as, what would make that the number 1x? Well, what times 5/7 would give me 1? And the answer is the reciprocal, or 7/5, because 5 over 5 is 1, 7 over 7 is 1. Then that gives me 1x. But if I do this to the left side, I also have to do it to the right side. Now, notice how I put this as the 7 on the top, the 5 on the bottom, because in my brain I am seeing this. This helps you not think of 20 and 7/5, but 20 times 7/5. So the answer is going to be whatever that is. Well, I know that 20 is 4 times 5, and the 5s will cancel. So it's going to be 4 times 7, or 28 is the answer. So 5/7 of 28 is 20, is the question. Okay, again, that is review. What we're going to do this week in lesson number 25 is going to put those two together into a single problem. And so you'll have problems like this: 2/5 x minus 3/10 equals 1/2. And you're supposed to find out what is x. We're going to use the same concepts that we did before, where my goal is, what is x? So this is how your brain should work on this. You should be looking at this thing saying, you've got a left side, you've got a right side. Okay, where's the x? It's over here. So what else is over here? Well, I have a negative 3/10. How do I get rid of negative 3/10? Well, if I add 3/10, what's negative 3/10 plus positive 3/10? 0. But if I add it to the left, I'm going to add it to the right. And so now I have 2/5 x equals this thing. Well, let's get a common denominator here. Multiply top and bottom times 5. And I end up with 5 plus 3 over 10, or 8/10, or 4/5. Okay, so first thing I do is I look if they're just a number that you either add or subtract. Do the opposite. In this case, it's a negative number, so I'm going to add that number and move it to the other side. So I add this, and then this whole thing will go away, and it will essentially, you'll put something over here instead. And then you solve that and you get this answer. Now this is like what we saw just a few minutes ago. I have something times x equals this. Well, I want this to end up being 1 times that. So I just multiply by 5 over 5 cancels that. But if I do it to the left, I have to do it to the right. And 5's cancel, and 4 over 2 is just 2. And so solve the problem. So there's always going to be well, I shouldn't say there's generally going to be 3 steps. There might be less than 3 steps. First step is move the numbers to the other side. Second step is simplify that side. And then the third number is you're going to multiply the reciprocal or divide the number in front of the letter. Okay. Long way of saying it, but that's actually what happens. So let me do that using these 3. I'm going to erase this upper section and show you how this might work from a easy problem to a more complicated problem. Okay, so let's start with the basic number. I have 2x plus 3 equals 11. Step 1, move the number to the other side. This is the number. I have a thingy and another thingy. This is the number thingy. I'm going to move the number thingy to the other side. I do that by subtracting 3, because 3 minus 3 is 0. But I'm going to do that to both sides. So I have 2x equals, moved it to that side. Now I'm going to simplify this. That's 1 minus 3 is negative 2. Now I'm going to do the third part, which is multiply times the reciprocal, or just, in this case, divide by 2. 2 divided by 2 is 1. But if I do it to the left, I have to do it to the right. And negative 2 over 2 is negative 1. Answer. So if it is a fraction, I multiply times the reciprocal. If it's not a fraction, I just divide by whatever number's in front of the letter. Okay, let me do that again using these basic 3 steps. Let's try another one that you'll see in your homework. Let's go with, this is number 13. So on number 13, you have 1/8 m minus 1/4 equals 3/4. Okay, first step, move the number to the other side. So I have a thingy and another thingy. One of those is a number. Okay, great. I'm going to add 1/4 to both sides. This will go away. Okay, 3/4 plus 1/4 is 1. That's the second step. So I have 1/8 m equals 1. Now I could do that in my head and it's 8. But I'm going to go ahead and do step number 3, multiply, because it's a fraction, times the reciprocal. 8 over 1. And 8's will cancel, 1's will cancel, and I end up with m equals 8. 1 times 8 is 8. Okay, so this is using these 3 steps. It'll always be 3 steps. It's not going to be more complicated than that. Sometimes you won't have to move something to the other side, and so you actually get to skip a step. I'm going to do another couple of these, or at least one more. And I'm going to do this one with decimals, just so you know the decimals work. And we'll work on these a little bit more on lessons 25, 26 with decimals. But so here's one. This is actually problem number 14. 0.5x minus 0.2 equals 0.15. Now you can use a calculator, so it's perfectly fine, but the steps don't change. I have a thingy and another thingy. Okay, how do I get rid of the number? Okay, well, if I add 0.2, so I'm going to add 0.2, and those will go away. And so I will end up with 0.5x equals 0.15 plus 0.2 is 0.35. Now, to get the answer, just divide both sides by 0.5. Do that on your calculator, and you'll end up with, and it'll end up being 0.7 if you do that on your calculator. Okay, so 3 steps, 1, 2, 3. Always works, every time, and that's all you have to do. All right, so now let's move on to the next lesson. Next lesson is lesson number 26. Lesson 26 is, what if they're a little more complicated? You still have 3 steps, but maybe a 4th step. I'll call it the 0th step. Okay, so the idea behind this is, what if there's not just 3 things? So this is an example. 3m minus 7m equals 8m minus 6. Okay, so this is the 0 step. Remember step 1, 2, 3. Step 0 is simplify, if possible. So you want to get it as simple as possible. So for example, 3 monkeys minus 7 monkeys is negative 4 monkeys, right? Equals 8m minus 6. My left side is as simple as it's going to get. My right side is as simple as it's going to get. I want eventually to have m equals. I generally make it on the left side. If I look at this and I say, okay, I have 8m on the right, I don't want 8m on the right. So if I subtract 8m, what is 8m minus 8m? 0. Okay, but I'm also going to have subtracted from the left. So now this will go away, and I will end up with negative 12m equals 6. Or negative 6, sorry, negative 6. So I've now kind of done step 1 there. I've moved the letters to one side, the numbers to the other side, and now step 2 is simplified it as much as I can. It is. Step number 3 is divide this by negative 12. And negative over negative is a positive, 6 over 12 is 1/2. And I'm done. So it doesn't matter how many complicated things there are, is if you just simplify both sides first, you'll end up with the same 3 steps. So it's not really more, it's just differenter. All right, let me do another one that's got a little bit more complicated look to it, but it is the same concept. All right, so let's go with, I'm going to pick problem number, D on your practice problems. This one is 3, this is number D. It's right after letter 1, right before letter 1. Anyway, 3p plus 7 equal minus a negative 3 equals p plus a negative 2. Okay, that's what it shows up. Well, let's just do step 0. Simplify. Well, I have a thingy, 3 p's, p's over there, and then I have numbers. Okay, let's see if I can simplify the numbers. What's 7 minus a minus 3? Well, that's just 10. 3p plus 10. Over here, I have p minus 2. Okay, so now let's do that second step. Let's put this p over here. So I do that. If I subtract p, what's p minus p? 0. So those will go away, but I also must subtract it there. And so I end up with 2p on this side. And this is 2p, and this is not 2p. So that is the question. So you're going to say 3p minus p is 2p. And if you have 2p, the bathroom is out the door, but never mind, that's a different question. So here, if I subtract 10 from both sides, this one will go away. And I will end up with negative 2 minus 10, negative 12. So notice I kind of did this 2 things in one step. I took all the letters, grouped them to the left, took all the numbers, and pushed them to the right. And then I do my step 3, which is the number in front of the letter. I just divide both sides by that. Because 2 over 2 is 1, so I end up with p equals negative 6. Okay, I'm going to do that one more time. I'm going to do letter B, which is very, very similar to that on the practice problem, just so this is super duper clear for you. And Again, I'm showing it as how most people do it rather than writing out one extra step, which can be confusing, but I think honestly, everybody does it this way, so teaching you now is probably better than waiting. 6p equals 9p minus 7 plus 8p minus 3 plus 2p. Okay, what's your simplest thing you're supposed to do? The zeroest thing is to simplify it. So notice I have 5 minus 6p. That's as simple as that side gets. So I'm going to leave it. 5 minus 6p equals something. However, here I can simplify. I have 9p plus 8p plus 2p. So 9 plus 8 is 17, plus 2 is 19. So I have 19 pigs. Then I have -7 numbers, -3 numbers. So I have -10 numbers. So now it's simplified as most as possible on both sides. I can't combine the p's and the 10s because this is a thingy, this is a thingy, these are numbers, these are numbers. Thingies and numbers cannot be connected. Okay, so now my goal is I'm going to put all the letters over there and all the numbers over there. Okay, I have a 5 on this side. To get rid of it, I'm going to subtract it. I'll subtract it from this side also, and it goes away. I have 19p. If I subtract it, I have to subtract it here, and then this goes away. And so I have -6 minus 19 is -25 p's. And over here, -10 minus 5 is -15. So that is step 1 and 2 kind of comboed there. And then next step 3, divide both sides by -25. And I end up with p equals negatives over negative is positive, 15/25 is 3/5. And I'm done. This is how you do more complicated ones. And that's all there is to it. More complicated ones is the same, essentially 4 steps. And again, I say, as I did before, there's usually 3 steps. Notice this one was kind of 3 steps, but it can be less than 3 steps or can be kind of a complicated version of 3 steps. But it always ends up the same pattern. Simplify, move the letters to one side, the numbers to the other side. Then you'll end up with something like this where you have to divide or multiply times a reciprocal, and you're done. Okay, and let's go with lesson number 27 now. Lesson number 27 is going to introduce a new concept as well as giving you practice at these ones that we've been just doing. Okay, so first thing on lesson 27, just want to review this idea. If I have this and I want to do this, there's 2 ways to do it. I can say 3 plus 2 is 5 and 4 times 5 is 20. I can also use what is called the distributive, and it is one of the most common things that we do in algebra is we use the distributive property. What this means is if you have something in front of a parenthesis, you're saying generally this times everything in that parenthesis. So what I'm going to do is I'm going to, in my head, say 4 times 3, 12, plus 4 times 2, 8. Well, what's 12 plus 8? 20. That's the same answer, but it is solving it using what's called the distributive property. Where you don't use this is in arithmetic, because you just add the numbers. Where you do use it is in algebra. So let's say I have something like this, xy, parenthesis, y squared minus x squared z. And I said, what is that? And the answer is, I don't know. Yes, you do know. You just multiply it out and see. You're going to end up with a bunch of letters as your answer. So I don't know is not really a good answer. You're going to end up with a bunch of letters. The correct letters is the answer. So I'm going to say, what's xy times y squared? Well, that's xy, y squared, or xy to the third. And then I'm going to say minus, because that's a minus, What's xy times this? Well, that's going to be xy x squared z. Or x times x squared is x to the third y z. This is your answer. That's it. It's a bunch of letters, but that's the correct letters. And notice I went in alphabetical order, x, y, z. That's all there is to it. That is using the distributive property. These can look really, really ugly, but they're not actually that complicated. So let me give you an example of one that looks ugly, but you should be able to follow. This is on page 114, and it's all written out for you in great detail should I blow by it too fast. So you have this is example 27.4. Okay, and it says, okay, use the distributive property to do this one. Well, this is 8m squared x, parenthesis, 5m to the third x minus 3x to the fifth plus 2x. Okay, so this looks ugly, but it's not that complicated. It is this times this. What's 8 times 5? 40. M squared times m to the third is m to the fifth. Remember, this is just m times m, and this is m times m times m. How many m's? 5 m's. And then x times x is x. There's two x's. X squared. Minus, so whatever that symbol is, that's what you use, minus this times this. 8 times 3 is 24. M squared, there are no m's, so I just leave it m squared. X times x to the fifth is x to the sixth. Plus, because it's a plus, this times this. 8 times 2 is 16. M squared times that is m squared. X times that is x squared. The answer. That's it. That's all there is to it. You're just saying in a problem like this, you're saying this times this plus this times this plus this times this. And again, pluses are because there are plus signs there. And that is how you do those. So let's do this last part of lesson 27. And that is introducing a word that is not that complicated, but it confuses everybody. And that is, oh, wait a minute. Maybe I should, maybe I shouldn't. That's good enough. That's lesson 27. So this week you have lessons 25, 26, 27, and I will see you in class.